Alright, welcome to the last of the Chapter 7 videos. So today is the 7.5 video, and the beginning of what I was going to do was go through some review examples, but what I think I'll do instead is start out with the new stuff, and then I'll go back and do some review problems. So if you want to stop watching after the new stuff, you're welcome to do that. So let's start with this problem. It says, write a polynomial function p in factored form and in standard form by using the given information. So the polynomial is of degree 2, and p of 0 equals 12. And then the zeros are 2 and 3. So we're really working backwards. We typically would solve problems by finding the zeros. Now they tell us what the zeros are, and we have to write an equation for that. So I'm going to do that. I know my zeros are 2 and 3, so that means my equation, p of x, if the zeros are 2 and 3, it's going to be x minus 2 and x minus 3. Okay? And then that's it. It's of degree 2, and the zeros are 2 and 3. Now the problem is, it says p of 0 equals 12. And what that means is, if we put 0 in for x, we're going to get negative 2 times negative 3, which is not 12. That's 6. But they tell us that p of 0 has to be 12, so how can we make it so that the zeros are still 2 and 3, and when you put 0 in, you get 12? Well, there's kind of a quick fix to that. P of x will just put a 2 out in front, because 2 times 6 is 12. So now if we put a 2 out in front, we'd have 2 times negative 2 times negative 3, or 2 times 6, which is 12. So we have our equation. I'll rewrite it down here so it's not as sloppy. It's p of x equals 2 times x minus 2 times x minus 3. And this is in factored form. Okay, so then they ask you to write it in standard form as well. So we got factored form down. Now we need to do standard form. And standard form is just multiply out these two binomials. So many of you know it as FOIL. So x times x, that's x squared. And then minus 2x minus 3x. And I got the minus 3x by negative 3 times x. And then negative 3 times negative 2 is plus 6. And then we'll distribute the 2 into everything. And so this would be 2x squared minus 4x minus 6x plus 12. And then we could combine like terms, so it'd be 2x squared minus 10x plus 12. And so this is standard form. If you hear that noise in the background, it's just the STEP team practicing. Don't be alarmed. Okay, so we get 2x squared minus 10x plus 12. So we found an equation that satisfied all of these conditions. It's degree 2, because it's x squared. P of 0 is 12, and the zeros are 2 and 3. Wonderful. Alright, let's do another one. I think we have 2 more examples like this. So this one is, write it in factored form and standard form again. This time it's degree 3, p of 0 is 20, and the zeros are negative 2, 1, and 2. Okay, so we'll start with p of x equals, well, I know my zeros are negative 2, 1, and 2, so it's going to be x plus 2, x minus 1, and x minus 2. Okay, so this is our factored form. It's degree 3 because if we go x times x times x, x to the third. But if we put 0 in for x, I don't think we're going to get 20. Let's try it. That's going to be 2, -1, and -2. 2 times -1 is -2, times -2 is +4. But we want it to be 0. So, what times 4 would give us 20? Well, 5. So that means we'll drop a 5 out in front. So the leading coefficient here is going to be 5. Alright, so we have our answer. This is in factored form. Oops. Factored form. And now to write it in standard form, we're going to have to do some multiplying. And this is going to take a little bit of space. So what I'm going to do is I'm going to multiply these first two. It's going to be x times x is x squared. I should probably not forget that 5 out in front. Um, 2x, or 2 times x is 2x. X times -1 is -1x. And 2 times -1 is -2. So all we did so far was we combined those two terms. Okay. Before I multiply this one by the x minus 2, I'm going to combine the like terms here as well. So it's 5x squared plus 1x minus 2, and then x minus 2. Okay, and then now what I would do is I'm going to take this trinomial and multiply it by this binomial. So we've looked in the past, we've used the box method. And I might as well do that again. So if you like a different method, you can use that other method. So I'll make a rectangle. Looks more like a parallelogram. So we'll put x minus 2 on top, and then x squared plus x minus 2 on the side, and we'll just multiply. So x squared times x is x to the third. X squared times -2 is -2x squared. X times x is x squared minus 2x minus 2x, and, plus 4. So when we multiply these two, we get, we'll have the 5 out in front. It's going to be x to the third, and then minus x squared, and then minus 4x, and then plus 4. Okay, so then we multiply 5 into everything, we get 5x to the third minus 5x squared minus 20x plus 20. And so this is our answer in standard form. Great. Okay, so 2 down, 1 to go. And this last one is going to throw a little bit of a loop in here, so this one's a little bit different. It says, write a polynomial function p in standard form. So this time they're just asking for standard form by using the given information. It's degree 3, p of 0 is 4, and the zeros are -1 and 2i. So this time it's going to have an imaginary root at 2i. So, we'll start with p of x equals, and so I know one of the zeros is x plus 1, or one of the factors is x plus 1, and the other is x minus 2i. Okay, but complex roots, they're kind of needy. They can't be all by themselves, they need some attention. And so they always come in pairs. They're like twins. The other complex root, instead of x minus 2i, is x plus 2i. So on every problem that we're going to be doing, if we have a complex root which is 2i here, the other root is also going to be negative 2i. So they'll always come in pairs, one being positive and one being negative. So if, for example, it was one of the zeros was 1 plus 3i, the other one would be 1 minus 3i. They're always complex conjugate pairs is what they are. But this isn't for our problem, so we'll just kind of ignore that. Okay, so this is going to be degree 3 because it's x, x, and x. So degree 3, that's good. P of 0, is that going to be 4? Well, I'm not 100% sure. Let's try it. So P of 0 would be 1 minus 2i and then 2i. Alright, so let's multiply these. 1 times negative 2i times positive 2i. That's going to give us negative 4i squared. Well, I squared, as we know, is negative 1. So we'll replace that with just negative 1. Okay, so negative 4 times negative 1, that is positive 4. And guess what? P of 0 is 4. We're good to go. We don't have to multiply it out in front by anything. So P of 0 is 4. That's good. Now all we have to do is write it in standard form. We got the zeros, we got the degree 3, we got the P of 0 equals 4. So now we just have to FOIL this out and write it in standard form. So whenever you have complex conjugate factors, you want to multiply those together first. They're going to cancel out nicely. So I'll do that in red at the bottom here. So we'll have x plus 1. And then when we multiply these, we get x squared minus 2ix plus 2ix. And then minus 4i squared. Okay, I said this cancels out nicely. It doesn't look very nice right now, but trust me, it does. So this is P of x. So we get x plus 1, and then we get x squared. Well, if we have minus 2ix and plus 2ix, hey, that's pretty sweet. Those cancel out. And then minus 4i squared. Well, we already noticed up here that minus 4i squared is the same as 4. So it's just x squared plus 4. So that is pretty nice. That all the i's just cancel out and we're left with x squared plus 4. Okay, so then if we multiply these together, we'll FOIL it. X times x squared is x to the third. X times 4 is 4x. 1 times x squared is x squared. And then 1 times 4 is 4. So I should have planned this a little more carefully. Standard form means the x to the third has to come first, the x squared has to come second, the x, and then the constant term. So I just need to flip around those two middle terms. X to the third plus x squared plus 4x plus 4. So this is our answer. P of x is that. It's in standard form. The zeros are negative 1, 2i, and negative 2i. And it's degree 3. So that looks fantastic. So one of the things that I have here, the complex conjugate theorem, if it has a complex root a plus bi, then it also has the complex conjugate root, which is a minus bi. So this is exactly what I mentioned on that previous problem. Okay, so if you're good and you do not need to look at some review problems, you can pause the video or you can just stop the video. The homework, I'm not going to add any more book assignments. We'll just finish up that purple packet, the review packet, tomorrow in class. So no additional homework, just the review packet. Alright, so let's go back up. Let's look at some practice problems. This one says find the zeros of this polynomial. And so this one I notice, I'm going to try factoring by grouping. It's an x to the third. And I kind of notice that it is going to work. So I'll pull out an x squared here. And what's left over is x minus 4. Then I'll pull out a negative 3. and I get x minus 4 again. And so then if I factor out the x minus 4 out of both of these terms, I'm left with x squared minus 3. Oops, pardon me. 3, not 30. Okay, so it says find the zeros of each polynomial function. So when will this equal 0? Well, it'll equal 0 when this is 0, or it'll equal 0 when this is 0. So it's x minus 4 equals 0, or x squared minus 3 equals 0. So in this case, x would be 4. And in this case, well, we're going to have to do some solving. So we'd add 3 to both sides. We get x squared equals 3. And then we square root. We get x equals plus or minus the square root of 3. So those are our 3 zeros. 4, root 3, and negative root 3. Okay. Next practice problem. This one says find all the zeros of this polynomial. So this one is not going to factor by grouping. I can already tell you can't pull out anything here. So I'm going to have to bust out the calculator. So I'll get out my graphing calculator. And I'm going to type this into my y equals. I don't care. Oops, wrong one. So it's 3x to the third minus 10x squared plus 10x minus 4. 3x to the third minus 10x squared plus 10x minus 4. Okay, so now I'm going to graph it and look and see where that crosses the x-axis. It looks like it crosses here at positive 2. I'm not 100% sure there. It looks like it might not, but the way I can check is to look at what happens at positive 2. So I'm going to put a 2 up in the box, and I'm going to do synthetic division to prove that it actually does cross at positive 2. If it doesn't, then I've got a problem on my hands. So I'll write down the coefficients of this polynomial. Drop down my 3. 2 times 3 is 6. Negative 10 plus 6 is negative 4. 2 times negative 4 is negative 8. 10 plus negative 8 is 2. And 2 times 2 is 4. So my remainder is 0. That's fantastic. That's what I'm looking for. So that means that one of the zeros is 2. Okay? The other zeros are going to come from this. It's 3x squared minus 4x plus 2. Okay, so this one, I don't think it factors. Kind of out of luck there. So I'm going to have to use the quadratic formula here. So, it's x equals negative b plus or minus the square root b squared minus 4ac. All of that over 2 times a. Okay, so it's 4 plus or minus the square root of 16 minus, let's see, 12 times 2 is 24, all over 6, which is 4 plus or minus the square root of negative 8, all over, sorry about that, all over 6. So we get 4 plus or minus, well, you can't do the square root of negative, oh wait, yes you can. It's going to be an imaginary number, so it's going to be, let's say, the square root of negative 4 times the square root of 2. We broke up negative 8 into negative 4 and 2, which is 2i root 2 over 6. So I just simplified the square root of negative 8 to 2i square root of 2. And then 4, 2, and 6, these are all divisible by 2. So we can simplify this just a little bit more. It's 2 plus or minus I square root 2 all over 3. So these are, oh my goodness. These are 2 of my zeros, and then the other 0 we found up here is 2. So let me refresh my memory here. It's 2 plus or minus I root 2 over 3. Okay, this is 2 zeros here, one's plus and one's minus, and then this is the other one. So there are 3 answers, and I know there has to be 3 answers because it's an x to the third. And I also knew that this was going to be an imaginary answer, because if I look at my graph, it only crosses the x-axis one time. And so if it only crosses once, that means that the other answers have to be imaginary answers. Or complex, I guess. Okay, one last review problem. Find the zeros of this one. I don't think I'm going to have time to do this on the video. If you want, I can help you out with this on your own. But what you have to do first to start out is we do x to the fourth. We have to write it in standard form. Plus 4x to the third. Well, what the heck, I'll just do it on the video. Plus 16x minus 20. And so if we plug that in, alright, so x to the fourth plus 4x to the third oopsie. Minus x squared plus 16x minus 20. Alright, so we'll graph this. What we're going to do is we're looking for where it crosses the x-axis. And so it looks like it crosses at 1 and at 1, 2, 3, 4, at negative 5 as well. So we'll go to our notes, and I'm going to put 1 in the box, and hopefully that is one of my zeros. And so we'll drop down the 1. 1 times 1 is 1. Add those, we get 5. 4. 1 times 4 is 4. Add those, we get 20. 1 times 20 is 20. So my remainder is 0. So 1 is one of the zeros. That's good. We did our synthetic division and proved that it's one of the zeros. That's an ugly comma there. Okay. Another 0 then, we're hoping is negative 5. So what I'm going to do is I'm going to put negative 5 in the box. I'm just going to use what's left over here. And what I'm trying to do is get it down to a quadratic because I'm really good at quadratics. I know how to use the quadratic formula. And so once I get it to a quadratic, I'll be able to use many of those techniques we've learned in Chapter 5. Okay, so drop down the 1. Negative 5 times 1 is negative 5. Add these, we get a 0. Negative 5 times 0 is 0. Bring down, or add these, we get a 4. Negative 5 times 4 is negative 20. Add those, we get a 0. And so that's also very good. That tells us that the remainder is 0. So negative 5 is also one of our zeros. Okay, but I know there has to be 4 zeros because it's an x to the fourth. So we're going to use our answer here. That is x squared plus 4. And I'm going to solve this one to figure out the other 2 zeros. So I'll switch up colors here so that we can see we're kind of transitioning to a new idea. So if it's x squared plus 4 equals 0, I will subtract 4 from both sides. We get x squared equals negative 4, and then we square root, and we get x equals plus or minus Square root of negative 4. The square root of negative 4 is just 2i. So it's going to be plus or minus 2i. Wonderful. So we have our 4 answers. We know that there has to be 4 zeros. There are 1, negative 5, 2i, and negative 2i. Alright, so that's it for this video. And once again, there's no additional homework other than just finish the review packet.